So this is how we do in the integrated rate law. We go into the lab, we perform the experiment. As the time passes by, you see the decrease in the concentration of your reactant. And this is exactly what you will do in the iodine club one. And you will get the data in the concentration, molar concentration, and the time, and then you start plotting that. How you plot that? You first plot it where you just plot the data exactly the concentration versus time, and see that it's not the curve fitting is not aligned to the dots that you have for the data. So then what you did, you took the natural log of all the concentration and then plotted it against the time, and then it still is not following the data, the curve fitting. Then you came here and you tried it for the third time, but this time you the reciprocal of the concentration versus time here, and you see that it's beautifully fitted to the line that you have here. And that's where you're going to say that the reaction is following the second order kinetics. Okay, this reaction that we have performed here is following the second order kinetics. Then you're going to get the equation here. And when you are doing it on Excel, the Excel is going to give you the value of K, and it's going to give you the value of B intercept, which is going to be your initial concentration. Oh, no, Y intercept. Okay. So Y intercept and the M are given through the equation of the curve fitting from the plot, and then you can do a lot of calculations with that equation after plotting the data. So these are just the summarization for the units. This is the summarization for the half-lives for all the reactions. And this is how you're going to have the plots of half-life for the second order, the first order kinetics. You can have a guesstimate about how it's going to go down like 50 and then half, and how it's going to go, the concentration is going to go over time. So that's kind of a trend that you can focus on. And what you see the difference between the two is for the second order versus the first order kinetics. It's that from it's 1 minute for the half-life versus a half. So this is also a minute for the half-life of, but the concentration goes from here to here versus it goes from here to here, which is at A2 right here. Yeah. So time is in arbitrary units. What you see here is like third or fourth half-life. So first half-life, second half-life, second and the third one. Time between the second and the third one is saying that it's going to go all the way from 2.5, 3 to 3, 4, 5, 6, and 7, 4 minutes. And here it's just a minute, if it is in minutes. So it starts good, but as it moves forward, and you see that first order versus the second order kinetics, it's going to take longer. Collision of the model, collision model of the reaction. I've already discussed that initially.